Before we begin, take a moment to subscribe to this channel. Here, we uncover how the world's most powerful industries actually work from the inside out. Every single day, more than 2 billion bottles of cola are consumed around the world. From small villages to megacities, from street vendors to luxury hotels, the same dark liquid flows endlessly, cold, fizzy, and familiar. But almost no one ever asks the most important question: how is cola really made? Not the version shown in commercials, not the glossy advertisements filled with happiness and smiles, but the real process inside, massive factories where machines never sleep, where precision matters more than flavor, and where a single mistake can cost millions of dollars. Behind every bottle of cola lies a billion-dollar system. A system built on chemistry, automation, logistics, and extreme efficiency. And today, we are stepping inside that system. At first glance, cola seems simple. Water, sugar, flavor, carbonation. But that simplicity is an illusion. In reality, cola production is one of the most tightly controlled manufacturing processes on Earth. The formulas are guarded, the machines are calibrated down to milliseconds, and the factories operate like military operations, precise, silent, and relentless. Every second, thousands of bottles are filled. Every minute, kilometers of conveyor belts move without stopping. Every hour, entire cities are supplied. And yet, the process remains invisible. Imagine a factory so large that trucks line up day and night. So automated that human hands rarely touch the product. So optimized that a delay of just 5 minutes can disrupt supply chains across entire regions. This is not just food production. This is industrial engineering at its highest level. But before cola ever reaches a bottle, before it is chilled, sealed, and shipped across continents, it begins with something far less glamorous. A liquid concentrate, measured in grams, protected by layers of secrecy. A formula so valuable that only a handful of people in the world are allowed to fully understand it. And that is where our journey begins. In this documentary, you will see how raw ingredients are transformed into a global product, how modern factories produce millions of bottles every day, why automation is more important than human labor, how quality control prevents disaster at massive scale, and how a single factory can generate billions of dollars in revenue. But more importantly, you'll discover why cola production is not just about drinks. It's about power, efficiency, and control. As we move deeper inside the factory, things become faster, louder, more complex. Machines communicate with machines. Sensors detect microscopic errors, and every movement is tracked, logged, and optimized. Nothing is left to chance. Because when you're producing for the entire world, failure is not an option. So stay with us. Because once you see how cola is truly made, you will never look at a bottle the same way again. Long before cola became a global icon, before factories, conveyor belts, and automated bottling lines, cola began as something far smaller. In the late 19th century, the world was changing rapidly, and people were searching for products that promised energy, refreshment, and modernity. It was in this environment that the first cola-like beverages appeared. Not in massive factories, not in glass bottles, but in small pharmacies, mixed by hand, sold by the glass. At the time, cola was not marketed as a soft drink. It was marketed as a tonica product, believed to refresh the body and stimulate the mind. Few could have imagined what would follow. As demand increased, producers quickly realized something critical. Cola was not just a drink. It was scalable. Unlike fresh foods, cola could be standardized. The taste could be replicated. The ingredients could be transported. And the product could be produced almost anywhere if the process was controlled. This realization changed everything. By the early 20th century, cola production shifted from small-scale mixing to industrial manufacturing. Factories replaced pharmacies, machines replaced manual labor, and consistency became the highest priority. No matter where a bottle was produced, no matter the country, the climate, or the factory size, it had to taste exactly the same. This demand for consistency would later shape one of the most advanced production systems in the food and beverage industry. As global transportation improved, cola followed. Railways, ships. Eventually, airplanes. The drink spread across continents, adapting not its taste, but its production scale. What once served dozens of customers per day, now served millions. Then hundreds of millions, and eventually, billions. With each expansion came new challenges. How do you produce cola fast enough to meet global demand? How do you maintain quality at massive scale? How do you prevent contamination, variation, or failure? In the 20th century, cola factories had become highly technical environments. Chemists refined formulations, engineers designed faster bottling lines, and quality control systems became increasingly strict. Factories were no longer just places of production. They became data-driven ecosystems. Temperatures were monitored. Pressure was calculated. Variable mattered. But there was another reason cola production grew so powerful. The business model. Instead of producing everything in one location, companies built a global network of factories. Centralized regional distribution hubs. This structure allowed cola to reach nearly every corner of the planet quickly, efficiently, and profitably. And it is still used today. By the time modern factories emerged, cola was no longer just a beverage. It had become a symbol of globalization. One formula, one process. Replicated thousands of times, from North America to Asia, from Europe to Africa, from megacities to remote towns. The same production logic powered it all. But this global success came at a cost. As production scaled, tolerance for error disappeared. A single contamination could destroy entire batches. A minor delay could disrupt regional supply. A small mechanical failure could cost millions. That is why modern cola factories operate with almost zero margin for mistake. And to understand how they achieve this level of precision, we must go deeper, much deeper. Before any machine starts moving at full speed, before bottles race down conveyor belts, before carbonation hisses into liquid, everything begins with control. Not production, not speed. Control. Inside a modern cola factory, raw materials are treated with the same seriousness as critical components in aerospace or pharmaceuticals. Because when you are producing billions of bottles, a tiny inconsistency can become a global problem. The most important ingredient is also the most underestimated. Water. Not ordinary drinking water, but industrially engineered water. When water enters the factory, it does not go directly into production. It passes through multiple filtration stages. Sand filters remove particles. Carbon filters remove organic compounds. Reverse osmosis strips minerals completely. What remains is water in its purest industrial form. Then, minerals are reintroduced deliberately. In precise amounts. Why? Because mineral balance affects taste, stability, and carbonation behavior. Too much calcium changes mouthfeel. Too little mineral content affects flavor perception. Every liter is measured. Every adjustment is logged. Next comes the sweetener. Depending on the region, factories use refined sugar or high fructose corn syrup. But the source is irrelevant compared to consistency. Sweeteners arrive in bulks, sometimes by tanker trucks or rail. They are stored in temperature-controlled tanks to prevent crystallization or degradation. Viscosity sensors measure flow behavior. Density meters calculate concentration in real time. If the sweetness level deviates beyond tolerance, production stops automatically. At this scale, almost correct is considered a failure. Then comes the most protected element in the entire factory. The flavor concentrate. It does not arrive like ordinary ingredients. It is sealed, tracked, documented. Access is restricted to authorized systems, not people. The concentrate is transferred through closed pipelines directly into controlled environments. No open air, no exposure. Even the quantity used is calculated by automated systems with no manual override. This ingredient is not just flavor, it is intellectual property, and its protection is built directly into the factory's architecture. Carbon dioxide is treated with equal seriousness. CO is stored under high pressure and purified before use. Moisture and impurities are removed to prevent instability later in the process. Temperature and pressure are continuously monitored, because carbonation does more than create bubbles. It affects shelf life. It affects taste release. It affects how the drink feels the moment it touches the tongue. Before production begins, every raw material undergoes inspection. Laboratory tests verify chemical composition. Automated sensors scan for contamination. Digital systems confirm compliance with internal standards. If one element fails, everything stops, not slows down, stops. This is why modern cola factories rarely suffer from major recalls. Problems are eliminated before production begins. The system is designed to prevent errors, not correct them later. By the time raw materials are approved, they are no longer just ingredients. They are inputs into a controlled equation. An equation that must produce the same result. Every time, everywhere, without exception. And now, with every variable locked into place, the factory is ready for the moment where chemistry meets automation. This is where the factory stops being quiet. Once the syrup is approved, everything accelerates. Pumps activate, valves open, conveyor systems begin to move. The process shifts from chemistry to industrial speed. The syrup leaves its secure holding tank through sealed pipelines. At the same time, treated water flows in from a parallel system. This is dilution, the moment when concentrated syrup becomes cola. But dilution is not simply mixing to liquids. It is a calculation. Flow meters measure volume per second. Temperature sensors monitor thermal balance. Software continuously adjusts ratios in real time. The goal is absolute consistency. A deviation of less than 1% is unacceptable. At this scale, even microscopic errors multiply quickly. As the diluted liquid moves forward, it enters the carbonation stage. Carbon dioxide is injected under pressure. But carbonation is not just about adding gas. It is about timing, temperature, and solubility. Cold liquid absorbs CO more efficiently. Pressure must be stable, flow. Speed must be synchronized. If carbonation happens too early, gas escapes. Too late, and bubbles become unstable. Sensors monitor dissolved CO levels constantly. If values drift, the system corrects them instantly or stops the line completely. Because inconsistent carbonation changes everything. Mouthfeel, taste, release, and shelf life. Now comes the most visually dramatic part of the factory. High-speed filling. Empty bottles arrive in massive numbers. They move so fast that individual motion becomes a blur. Before filling, bottles are cleaned internally. Air or sterilized water removes dust and particles. Then cameras inspect each one. Cracks, deformities, irregular shapes, anything suspicious is rejected immediately. Approved bottles move into the filling zone. Filling heads descend in perfect synchronization. Liquid enters under controlled pressure to prevent foaming. Fill levels are measured in milliseconds. Too low. Rejected. Too high. Rejected. There is no human decision here. Machines decide instantly. Once filled, bottles move directly to capping. Caps are applied at high speed, but not carelessly. Torque sensors measure how tightly each cap is sealed. Too loose, and contamination becomes possible. Too tight, and the bottle may fail under pressure. Again, anything outside tolerance is removed. The entire process from dilution to sealed bottle takes only seconds. Thousands of bottles per minute. Relentless, unforgiving. This is where efficiency becomes fragile. One malfunctioning valve, one sensor error, one mechanical delay, and the entire line can shut down. Downtime costs thousands of dollars per minute. That is why redundancy is built into every system. Backup pumps, secondary sensors, emergency shutdown protocols. The factory is designed not just to run fast, but to survive failure. As bottles leave the filling zone, they look complete. Dark liquid, sealed caps. Uniform shape, but appearance means nothing here. Not yet, because speed creates risk. And risk must be eliminated. By now, the cola looks finished. The liquid is carbonated. The bottles are filled and sealed. Everything appears perfect. But in a modern cola factory, appearance is irrelevant. Perfection must be proven. As bottles exit the filling line, they enter a zone dominated by sensors, cameras, and algorithms. This is quality control. And here, the rules are absolute. High-speed cameras scan each bottle in fractions of a second. They check fill height with laser precision. They inspect caps for alignment and integrity. They analyze labels for position, color, accuracy, and adhesion. Some of these checks happen faster than the human eye can process. Machines never blink. X-ray. Systems analyze internal pressure. They detect trapped air pockets, irregular carbonation levels, structural weaknesses invisible from the outside. If a bottle shows even the smallest anomaly, it is marked for removal. No explanation, no appeal. Rejected bottles are pushed off the line automatically. They never stop the flow. Efficiency demands sacrifice. At this scale, it is cheaper to destroy a product than to risk a defect reaching the market. But automated inspection is only part of the system. Random samples are pulled from the line continuously. These bottles are sent to on-site laboratories. There, technicians conduct detailed analysis. Carbonation stability tests simulate weeks of storage. Chemical analysis verifies composition. Sensory tests confirm flavor consistency. The question is not whether the cola tastes good today. The question is whether it will taste exactly the same, weeks or months from now. Environmental monitoring never stops. Air quality sensors detect contamination risks. Temperature and humidity are controlled to prevent condensation or microbial growth. Clean room protocols apply in critical zones. Because contamination does not always come from ingredients. Sometimes it comes from the air itself. Every data point is logged. Every bottle is part of a traceable system. If an issue is discovered later, the factory can identify the exact production line, the time of filling, the batch of syrup, the source of every ingredient. This level of traceability is not optional, it is required. Despite all this control, rejection is expected. Factories plan for failure. A small percentage of loss is built into the system. Not as a flaw, but as protection. Because perfection at scale is not achieved by hoping for zero mistakes. It is achieved by detecting and eliminating them instantly. Only after passing every inspection stage does a bottle earn approval. Not by human judgment, but by data. And once approved, the bottle moves forward without delay. Because the factory does not wait. But quality is not the end of the journey. After inspection comes the stage where speed meets geography, where local production becomes global supply. This is the point where cola truly begins to exist. Not as a drink, not as a finished product, but as a controlled chemical system. Once all raw materials are approved, they are released into one of the most restricted areas of the factory, the mixing and syrup creation zone. Here, human involvement is minimal. Not because people aren't trusted, but because machines are more precise. The process starts inside massive stainless steel mixing tanks. These tanks are not simple containers. They are engineered environments. Temperature is regulated to fractions of a degree. Pressure is stabilized. Internal surfaces are designed to prevent residue buildup. Before anything enters, the system performs a checked valves, sensors, flow meters. If one component fails, the system refuses to start. Water enters first. Not freely, but at a calculated flow rate. Immediately after, the sweetener is injected. This is not pouring. This is digitally controlled dosing. The system measures viscosity and density in real time. If the sweetener flows too slowly or too quickly, adjustments are made instantly. Nothing proceeds unless the balance is perfect. Then comes the most critical moment. The introduction of the flavor concentrate. This step happens inside a closed-loop system. The concentrate never touches open air. It moves through sealed pipelines directly into the mixing tank. Even at this stage, no one sees it. The quantity is calculated automatically based on batch size, temperature, and target profile. This is where the identity of cola is defined. A difference of a few grams at this scale can alter millions of bottles. As soon as all components enter the tank, high-precision mixers activate. Liquids move in controlled turbulence. Not too fast, not too slow. The goal is uniformity. Sensors continuously monitor the mixture's density, acidity, and color. Algorithms compare the data against reference models. If the mixture deviates, the system reacts immediately. Sometimes by adjusting mixing speed, sometimes by correcting ratios, sometimes by shutting everything down. Because a flawed batch cannot be fixed later. After mixing, the liquid becomes cola syrup. Thick, highly concentrated, not meant for consumption. This syrup is the backbone of the entire operation. From this point forward, everything depends on its accuracy. Before moving on, the syrup undergoes rigorous testing. Automated sampling systems extract small amounts and send them to on-site laboratories. There, technicians analyze chemical composition, stability, and sensory consistency. Taste tests are performed not casually, but scientifically. The question is not, does it taste good? The question is, does it taste identical to the reference standard? If the syrup passes, it is approved digitally. If it fails, it is isolated and destroyed. No reuse, no correction. At this scale, compromise is unacceptable. Approved syrup is then transferred to secure holding tanks. These tanks are monitored constantly. Temperature fluctuations are prevented. Exposure is eliminated. Access is restricted, because until the syrup leaves this stage, it is still vulnerable. This is the quietest part of the factory. No rushing bottles, no roaring conveyors. Just machines calculating, measuring, and waiting. Because the next stage will be the opposite. Fast, loud, relentless. Once a bottle passes inspection, it has only seconds to prepare for the outside world. Because speed now matters more than precision. Approved bottles stream into automated packaging zones. Robotic arms move faster than any human crew. They group bottles, align them, and seal them into plastic wrap shrinks perfectly around each unit, heated just enough to hold, never enough to deform. 4 glass bottles, cardboard trays slide into place. 4 cans, aluminum stacks interlock with mathematical efficiency. Nothing is random. Every movement is optimized for transport. Packaging is not about protection alone. It is about survival. Each box is designed to endure vibration, pressure, temperature shifts, and time. Transport simulations test how packaging behaves on highways, cargo ships, and air freight. Drop tests replicate accidents. Compression tests simulate stacked pallets. Thermal tests prepare products for desserts, snow, and humidity. A box that fails these tests never enters circulation. Palletizing happens at industrial speed. Robots stack cartons into precise formations. Weight distribution is calculated to the millimeter. One imbalance can cause collapse during shipping. Each pallet is wrapped, labeled, and digitally registered. A barcode connects it to a database that knows where it's going before it even leaves the building. From here, logistics takes control. Factories operate as nodes in a global network. Some pallets go to local warehouses. Others move directly to ports, rail terminals, or distribution hubs. Routes are pre-calculated using demand forecasts. Cities with festivals, holidays, or seasonal heat waves receive priority. The factory does not guess demand, it predicts it. Cold chain management becomes critical in certain regions. Temperature-sensitive monitoring devices travel with shipments. If limits are exceeded, alerts are triggered instantly. A delayed truck, a broken cooling unit, a shipping container exposed too long on a dock. The system knows and reacts. Distribution centers act as filters. Products are rerouted based on real-time sales data. High-demand zones pull inventory automatically. Low-demand areas slow distribution to prevent overstock. Nothing waits without purpose. Even returns and unsold products are tracked. Expired stock is recalled and destroyed. Damaged shipments are analyzed for pattern failures. Every mistake feeds the system. Every delay improves the next delivery. At this point, the factory's job is almost done. The bottle has traveled through chemistry, mechanics, inspection, and logistics. But one element remains: control. Because once the product reaches shelves, control disappears. Temperature varies. Handling becomes unpredictable. Human behavior enters the equation. Which is why everything before this moment must be flawless. Before the bottle reaches your hand, before the cap twists open, before the first sound of carbonation escapes, an invisible system has already done its work. Billions of times a year, people drink the same product, in different countries, climates, and cultures. Yet the taste remains identical. That is not coincidence. That is control at a global scale. Behind every sip lies a system designed to eliminate chaos. A system where chemistry meets logistics, where machines replace human inconsistency, where data predicts thirst before it exists. Factories do not simply produce beverages, they produce certainty. From raw ingredients sourced across continents, to microsecond-level filling precision, every variable is measured, modeled, and optimized. Water chemistry is adjusted molecule by molecule. Sugar ratios are locked within microscopic tolerances. Carbonation pressure is calibrated to match altitude, temperature, and shelf life. Nothing is left to chance. This is why a bottle opened in New York tastes the same as one opened in Jakarta, because the system refuses variation. But this precision comes at a cost. To maintain global consistency, local flexibility disappears. Machines dictate rhythm. Algorithms dictate timing. Human workers adapt to systems, not the other way around. Factories run 24 hours a day, not because people want them to, but because demand never sleeps. And demand is relentless. Billions of bottles. Every week, every month, every year, the system expands silently. More factories, more distribution hubs, more data centers analyzing consumption patterns. Not reacting to the world, but shaping it. Advertising creates desire. Logistics fulfills it. Manufacturing sustains it, a perfect loop. Yet the consumer sees none of this. They see a bottle cold. Familiar, trustworthy. They hear the fizz, taste the sweetness, feel the refreshment, and never question how much engineering was required to make that moment effortless. That is the power of industrial invisibility. When systems work perfectly, they disappear. But now you've seen behind the curtain. You've followed the journey from raw materials to high-speed production, from quality control to global logistics, from machines to markets. You now know that this drink is not just a beverage. It is one of the most advanced mass production systems ever created. And the next time you open a bottle, you won't just hear carbonation. You'll hear the hum of conveyor belts, the precision of filling valves, the rhythm of robotic arms, the quiet calculations of algorithms, and the scale of a system built to never fail. Final CTA. If you enjoyed this deep dive into the hidden world of industrial production, make sure to like, subscribe, and turn on notifications. Because this is just one system, and there are many more invisible worlds waiting to be uncovered. End title. Fade out. Mass production doesn't just shape products. It shapes the modern world.